Hello everyone, welcome to this video. In this video, we are going to solve the previous year questions from the engineering mechanics and theory of machines topic, which were asked in ISRO 2016 paper from the mechanical engineering branch. There are total 11 questions asked in this paper. Let's try to solve them one by one. Starting with the first question. An elevator has a mass of 5000 kg. When the tension in the supporting cable is 60 kilonewton, the acceleration of the elevator is nearly. So let's try to draw the free body diagram for it. So we have an elevator, and elevator has a cable, and the tension in the cable is 60 kilonewton. So it is 60,000 Newton, we can say, and the mass of the elevator is 5,000 kgs. 5,000 into into G is the weight acting in the downward direction. So imagine this, like the elevator is going up and the body is in motion, so we cannot directly apply the equations of the equilibrium. However, with the help of D'Alembert's principle, if we assume that the inertia force is acting in the in the opposite direction to the motion, then we can consider the body in a dynamic equilibrium. So assuming it, if the motion is in this direction, the mass times the acceleration inertia force will be in the downward direction. So we can say the tension, this is the tension, this is the weight. So we can say tension minus weight is mg is equal to the mass times acceleration. So tension is 60,000 minus weight is 5,000 times g is equal to the mass is again 5,000 times the acceleration. And if we solve it, if we assume roughly around g as 10, 60 minus 50 is 10,000. 10,000 divided by 5,000 will be 2,000. Sorry, 10,000 divided by 5,000 is 2. So acceleration will be 2 meter per second square. So the answer is option D in this case. Coming towards the next question. The piston of a steam engine moves with a simple harmonic motion. The speed of the rotation of crank is given, but it is in terms of the RPM, not in omega. With the stroke 2 meter, so indirectly they have given the radius of the crank. What is the velocity of the piston when it is 0.5 meter from the center? So let's write down the given data. Omega is equal to 120 RPM, so it's a 2 pi into 120 divided by 60. So it is 4 pi radian per second. Then the stroke, which is 2r, is equal to 2 meter. This implies r is equal to 1 meter. And what they have given is the velocity of the piston when it is 0.5 meter from the center. So total x will be r plus 0.5, which is 1 plus 0.5. That will be 1.5. Okay, from the center point it is so it is like half of the stroke plus 0.5 gives you the actual position. Then we know the formula. This x can also be written as r times 1 minus cos of theta. X is, we have calculated, is 1.5. The value of the r is 1. In bracket 1 minus cos of theta. If we calculate, it will give us the value of theta, which is 120 degrees. So the crank angle in this case is 120 degree. And corresponding to this value, what will be the velocity is what we are supposed to calculate. V is equal to r omega sine of theta r is 1. The value of omega is 4 pi and sine of 120 gives us the sine of 120 is under root 3 by 2. And the total answer in this case will be 2 pi into root 3 because this 2 will get cancelled. Yeah. So you can cancel it out and write it as 2 pi under root 3. Hence the option C is correct in this case. Coming towards the next question. So this is again, this is from the vibrations topic. The reading of the spring balance from 0 to 200 Newton and is 10 centimeter long. A body suspended from the spring balance is observed to oscillate vertically at 2 hertz. The frequency is given. The mass of the body is nearly. So they are asking us to calculate the mass. We know the frequency in hertz is 1 upon 2 pi under root k by m. We know this k is the stiffness and that is nothing but the load for deformation. Load is, we are increasing up to 200 Newton. So it is 200 and the elongation is 10 centimeters. So we can say it as 0.1 gives us the 2000 Newton meter of the stiffness value. Frequency is given as 2 hertz. So 2 pi into frequency, which is 2 hertz, is equal to under root of k by m. K is 2000 divided by m. So m can be written as 2000 divided by 4 pi bracket square. So this will give us close to 12.5 kg. Hence option B is correct in this case. Okay, coming towards the next question. Yeah, this is one of the theoretical question. A ball is dropped vertically from a height d above the ground. It hits the ground and bounces up to the height d by 2. Neglecting the subsequent motion and the air resistance, the velocity v varies with the height h above the ground is. So basically ball is dropped from certain height. So the you can say, and from that point let's say the velocity is increasing. So at, let's say, height d, you have the initial velocity 0 because it is dropped from the rest, and it is increasing, and then when it hits the ground, basically the it becomes 0, and then it bounces up. So the velocity, the direction of the velocity is changing. So from this figure, like, we can clearly see option B and D are incorrect because the direction of the velocity is like not changing in figure B and D. So that's why either A or C we have to focus. And then it is like bouncing in the upward direction now, up to the height d by 2. So yeah, so this figure is like cutting somewhere in between, or cutting exactly at the middle of 0 to d. However, the variation of the speed with respect to distance is like um, under gravity is not like this, not linear, and hence we know that with respect to distance d, if you say v square is equal to u square minus 2as, considering this nonlinear behavior, we can say that option A is correct in this case. Coming towards the next slide, we have a question which is related to the friction topic. In the figure shown, the minimum ratio of mu1 by mu2 so that the masses move together with the application of force F. So let's try to draw the free body diagrams of both the masses. We have one mass of 5 kg, which is kept on another mass of 10 kg. Starting with the free body diagram of 5 kg mass, it is pulled with some force F in the rightward direction. The weight is 5 kgs. So 5 into g is acting in downward direction. We have a normal reaction since it is kept on a surface of another block. So let's call it as N1, and we have the frictional force because there is a coefficient of friction mu1 in between 5 kg and 10 kg block. So mu1 N1 is the frictional force. F1 is equal to mu1 N1. So that will be like mu1 times 5g, 5 into 5 into g, or 5 into 9.81. So let's keep it in terms of g. Then this is the 5 kg block. Now coming towards the 10 kg block. Here we don't have any rightward force. However, we have two frictional forces. One is in between the ground and the 10 kg. That is, let's call it as F2, which is mu2 N2. When we are moving the 5 kg block in the rightward direction, the frictional force on the block 5 kg will be in the leftward direction. However, the frictional force on the 10 kg block will be in the rightward direction. So this is the direction of now F1 is mu1 N1. 10 kg force is 10 times acceleration due to gravity is the weight acting in downward direction. We have N2, normal reaction because of the ground is acting in upward direction. And we have N1, which is the Reaction because of the 5 kg block on the 10 kg block is N1. We already calculated it is 5g, 5 times acceleration due to gravity. Yeah, the value of, so from this figure number 2, we can say that in order to move both the blocks together, F1 has to be equal to F2. So we can say in order to calculate that, we should first find out the F2. F2 is equal to N2 mu2 N2 N2. So it is important to find the N2. We know that N2 is equal to, N2 is in upward direction, 10 times G is acting in downward direction plus N1. N1 is 5 times G. So 10 times G plus 5 times G is 15 times G acting in the downward direction. And from that, we can say that F2 has to be equal to mu2 into 15 times G. So according to the this freeboard diagram of 10 kg, we can say that summation of all horizontal forces is 0. So mu1 N1 has to be equal to mu2 N2. Mu1 N1 is equal to mu2 N2. Mu1 into 5 times G is equal to mu2 into 15 times G. G will get cancelled. So mu1 by mu2 is equal to 15 by 5, which is 3. Hence, option D is correct in this case. Coming towards the next question. A thin wire of length L and uniform linear mass density rho is bent into a circular loop with a center O as shown in this figure. The moment of inertia of the loop about this axis x dash. This is what we are supposed to calculate. So basically, let's first let me draw one axis here. Let's call it as x axis. Okay. So if you want to calculate the moment of inertia about the axis x dash, it has to be equal to moment of inertia about axis xx plus mr square, where let's say this is the capital R. This is the R. Now we know that this circular loop will have the moment of inertia mr square by 2. However, on top of that, we have to add this mr square. So 1 plus 1 by 2 is 3 by 2. Mr square will be the moment of inertia about this axis xx dash. However, the answers are not in terms of the mass. So you have to represent the mass in terms of the density and also the radius in terms of length. So let me go to the next slide and write down again Ixx is equal to 3 by 2 mr square. We know density. We know that density is equal to mass times volume. So mass is equal to density into volume. And yeah, assuming it is unit cross-sectional area, mass can be written as rho into 1 into L. It is like rho L you can write. Also, what is the length? The length is 2 pi r because it's 2 pi capital R. Capital R is the radius of the circle and the circumference will be 2 pi r, and that will be the total length of this wire. And hence r can be also written as L by 2 pi. So putting back into this formula, 3 by 2, M is rho into L, and R is L by 2 pi. Whole square. It will be like 3 by 8 rho L cube by pi square. So it's like 3 by 8 pi square, or let's say 3 rho L cube by 8 pi square. Looking into the option D is correct in this case. Coming to the next question. We have a 10 kg mass is hung from the two light inextensible strings as shown in this figure. The tension in the horizontal string is nearly. So let's try to draw the free body diagram here of this block. We can say that this block is subjected to two tensions. One is in this horizontal direction. One is in the 60-degree angle with the horizontal, because this alternate angles has to be equal. Let's call it as a T1, T2, and the weight is acting in the downward direction, which is 10 times the acceleration due to gravity. So let me write it. So we can have the three forces which are coplanar and concurrent. This is the way you can draw it. T1 in this direction, 10 times G in this direction, and we have T2, which is at a 60-degree angle with respect to the horizontal. This is 90 degree, and this has to be 120 degree. Now we know by using the sine rule, we can say that 10 times G has to be divided by sine of 120 degree has to be equal to T1 divided by sine of 90 plus 60 is 150 degree is equal to T2 divided by sine of 90 degree. We are interested in calculating the T1. So using these two formula, or using these two relations, we can say that T1 is equal to 10 times acceleration due to gravity into sine of 150 divided by sine of 120. The final solution you should get in this case is 56.6 something, which is approximately 57 Newton. Hence, the option B is correct in this case. Coming towards the next question. This one is again from the mechanics. We have a block which is made to slide down an inclined plane 30 degree with a horizontal, which is smooth. Since we don't have the friction here, friction is 0. It starts sliding from the rest, so initial velocity is 0, and takes time t to reach the bottom of the plane. An inclined body is freely dropped from the same height. The time of the body takes to reach the bottom is. So we have two situations here. One, in one first situation, the block is, let's say, sliding from some certain position, which is at, let's say, an inclined plane, which is 30 degree inclined to the horizontal. And in this case, we have the time t to reach the body to the ground. And in the another situation, we have the block. Okay, let's say the block is here now. And now this block is, we are dropping down, and how much time it will take to reach the ground. Yeah, of course the time has to be less than it, because here it is sliding, here we are just dropping it. So this is the first situation, you can say, and this is the second situation. Let's try to analyze both the situations one by one. So in the first situation, we can draw a triangle like this. Let's say this is point C, A, and B. Okay, ABC triangle. Body is moving from point C to point A in first situation, and in the second situation, body is moving from C to B. This is angle 30 degree. Sine of 30 degree is equal to 1 by 2 is equal to x by AC. So this implies, let's say this is x. So x is equal to, or let's say AC is equal to 2 times dx. Okay, keep it as equation number 1. So in the first situation, in the first case of sliding, initial velocity is 0, we know. So s is equal to ut plus half of at square. We'll try to find the distance and compare it with the 2x. So 2x has to be equal to 0 plus half of. So the acceleration g is acting in the downward direction. The component of the acceleration in that direction will be g sine of 60, sine 30, sorry, g sine of 30, because this also has to be 30 degree. G sine 30 into t1, or let's say t square. So this sine 30 is again 1 by 2. So we can write it as 2x is equal to 1 by 4 times g t square. This implies 8x by g is equal to t square. This implies t is equal to under root of 8x by g. Okay, this is the first case. Second case of dropping, okay, dropping the body from height x. So this distance traveled is x, we know, we already assumed it, and that is equal to ut again plus half of g t square. But now in this case, let's call it as t2. Okay, let's call this as a t1 now. Okay, let's call it as a t1. gt2 square we can say in this case. So this implies t2 is equal to 2x by g, 2x by g, and yeah, under root of it will be t2. Yeah, so we have the relation here in between t1 and t2. So what we can write is t1 can, how can we write t1? T1 can be written as like it can be written as 2 times 2x by g is equal to, let's say, t1. So we can say that t1 is equal to 2 times t2. This this implies t2 will be t1 by 2. So half of the time, half of the initial time it has to take. So the answer in this case is option B. We are just comparing the equation number 2 and equation number 3 and writing it. Coming towards the next question, this is from the mechanics. We have two forces which are acting at a point with an angle 60 degree between them. The resultant is given. What is the magnitude of each force? So we have two equal forces. Let's call them as P and P. The angle between them is also given to you, 60 degree. Imagine the resultant is something like this. This is the resultant. So we can say that resultant square is equal to P square plus 2 into P cos of 60, because both the forces are P. That's why we are writing it like this. Resultant is given as 60 root 3. So 60 into root 3, 60 root 3 square has to be equal to P square plus P square, which is 2P square plus 2P square cos of 60. So we can take 2P square common. Cos 60 is 1 by 2. 1 plus 1 by 2 is 3 by 2. And yeah, this will be like 60 square into 3 in short. So this 2 will get cancelled. This 3 will get cancelled. P square is equal to 60 square. So P has to be equal to 3 Newton. Hence option D is correct in this case. Coming toward the next question. This is again from the mechanics. We have from the truss topic, we have 2-member truss A, B, C, and is shown in this figure. The force in the member AB is what they are asking. So let's try to draw the free body diagram of joint B. The joint B has one force, 10 kilonewton acting in the downward direction. One force in the member AB. Let's call it as FAB. And in the member FDC. Okay, let's call it as a BA and a BC. So we don't know the angle here. However, they have given us the length of the member AB and the distance between point A and C. So imagine this is theta. We can calculate tan of theta. Tan of theta is equal to 0.5 divided by 1. So it's a perpendicular divided by the base. 0.5 divided by 1. This implies theta is equal to tan inverse of 0.5, which is 26.5 degrees. We have the value of theta now. We are supposed to calculate the force in the member AB, means we have to take we should know the horizontal component of FBC. However, in order to get the horizontal component of FBC, we should know the value of FBC first. We can also say that the vertical component of FBC has to be equal to 10 kilonewton. So comparing that, we can say FBC sine of theta has to be equal to 10 kilonewton. So FBC is equal to 10 divided by sine of 26.5 degrees is almost like 22.36 kilonewton is the force in the member BC. As I said, the horizontal component of a BC has to be equal to the BA force in the member AB, and so we can say that if BA is equal to 22.36 into cos of 26.5 degree, and this will be close to 2.36. Yeah, this will be close to 20 kilonewton. Hence, the option is option C in this case. So just by using the method of joints, we have solved this question. This is the last question now. The four forces of magnitude 20 kilonewton, 40 kilonewton, 60 kilonewton, and the 80 kilonewton are acting respectively in four sides of a square ABCD, as shown in this figure. The magnitude of the resultant is. We know how to calculate the resultant. The resultant is calculated by summation of all the horizontal forces plus vertical forces. First of all, we should calculate the all horizontal forces. We have 60 Newton in leftward direction and 20 Newton in rightward direction. So minus 40 is the, you can say, summation horizontal, minus 40 square. In vertical direction, we have 80 in upward direction and 40 in upward direction, 80 in downward direction. So again, minus 40 square. And yeah, it will be like 40 root 2. 40 root 2 Newton is the answer. Hence, option A is correct in this case. So that's all from the 2016 paper. Thank you all for watching this video. Hello everyone, welcome to this video. In this video, we are going to solve the previous year questions which were asked in which were asked in ISRO 2015 paper of mechanical engineering from engineering mechanics and the theory of machines topic. There are total 5 questions asked in this paper. Let's try to solve them one by one. Starting with the first question. This is from the projectile motion. A shell is fired from a cannon with a speed v at an angle theta with the horizontal. The direction is as shown in this figure. At the highest point in its path, it explodes into 2 pieces of equal masses. One of the piece traces its path to cannon. So one piece will go straight and one piece is coming back to the cannon from which we have fired it. The speed of the another piece immediately after the explosion is. So the one piece is, they are saying it is coming back. However, the speed of the another piece immediately after the explosion is what they are asking us at point B. P is the topmost point. The component of the velocity is in the horizontal direction only, because we know that as we go up and up, basically the component of the velocity in upward direction reduces and becomes 0 at this point where it reaches the maximum height, and then the velocity component will in vertical direction again increases, however in the opposite direction. If I draw the 2 components here, they are like this. Here they are like this, and at this particular point it is only in the horizontal direction. VB in vertical direction is 0. So this is only in the VB at the horizontal direction. So let's try to solve it. So whatever will be the initial momentum, it has to be equal to the final momentum. At the top, the momentum is like mv cos of theta, we can say. So at top point, mv cos theta is the, let's say, the momentum, and so this is before the explosion, we can say, and then after it will be divided into two pieces of equal masses. So we can say half of m by 2 mv by 2 cos of theta, since it is going back to the place from where it is fired. The velocity is in the opposite direction, so the minus sign has to come. However, the other piece has the m by 2 mass, and v dash is the velocity of the other piece. Okay, so you can see it is as the velocity of the, and this is like the piece which is coming back to the cannon. Now, if we simplify it further, mv cos of theta plus m by 2 v cos of theta is equal to m by 2 v dash. So it is 3 by 2 m v cos of theta is equal to m v dash by 2. Will get cancelled. V dash, so this 2 can also be cancelled. So v dash is equal to 3v cos of theta. Hence, option A is correct in this case. Coming towards the next question. A mass of 35 kg is suspended from a wetless bar AB, which is supported by a cable BC at pin A, as shown in this figure. The pin reactions at A on the bar ABR. So we are supposed to calculate the reactions at A, vertical and horizontal reactions. So let's try to draw the free body diagram of this bar AB. So let's say the AB bar, we have a vertical reaction and horizontal reaction. Mg is acting in downward direction. Then the tension force in this case is at an angle, let's say this theta. We can say tan of theta is equal to 125 divided by 275. So theta will be tan inverse of this, which is close to 24.44 degrees. Now, using this, let's call this as a theta. So this is how the free body diagram of the bar AB will look like. Now, you can take the moments at point A in order to calculate the tension, and then we can find out the vertical and horizontal reactions. Horizontal reaction will be the horizontal component of the tension, and yeah, by taking summation of all vertical power forces, we can calculate the vertical reactions. Taking moments at point A and equate it to 0, T, the cos component of the tension is horizontal component, which will not create any moment at points A. However, the vertical component is T, sine of 22.44 degrees, creates a moment because it is at a 275 mm distance. So you multiply by 275 mm, that has to be equal to the clockwise moment created by the weight, which is mg. Mass is 35 kg. 35 into 9.81 into 275. So this 275, it cancels out. Okay, maybe by 1000 you can say in terms of meters. And but yeah, it gets cancels, and tension is what you will get around 343. If you multiply 35 with a 9.81 and divide again with a sine of 24.44 is approximately 830 Newton. And now the horizontal component is what? HA is the horizontal component, that is equal to T cos of 24.44, and that is equal to HA. Okay, that is equal to how much? 7. That is approximately equal to 755 Newton. You will get something 754 point something, which is 755 Newton. We can, at this point itself, we can take that, we can say that where vertical reaction at point A is 0, because if we take the moment at point B, there will not be any moment because of the A, there will not be any moment because of the H, because it is along the same line AB. However, there will be moment about which will be created clockwise from by VA. So VA multiply by 275 equal to 0. This implies VA has to be 0. So VA is 0. You can confirm by taking moment about B and equating to 0. So 755 and 0 is the correct answer. Hence the option D is correct in this case. Coming towards the next question. We have a simple structure A, B, C, D, E is supported on hinge at point A and the roller at point B. It carries the horizontal force of 1000 kilonewton at point E, as shown in this figure. Determine the force in the member AC using the method of joints. So we are supposed to find the force in the member AC. In this, in order to do so, we should first find the reactions at the support and draw the free body diagram of joint A. So how will you find the reactions at the support? VA plus VB has to be equal to 0. Okay. There is no vertical force, external vertical force, so we cannot conclude anything. At this point, we can just say that VA is equal to VB. This implies VA is equal to minus VB, we can say. They are same, but in opposite direction. If we take the moment of this about point A and equating to 0, we will say that this 1000 multiply by this height plus 1 meter. So it will be like 1, this is 0.5. So this height has to be 0.87. Okay, you can calculate by using Pythagoras theorem. So it will be total 1 plus 0.87, so it will be 1.87. And yeah, the vertical force at point B creates the same moment. So it will be VB multiplied by 1. So this implies VB has to be 1870 Newton, and this implies VA has to be in opposite direction like this, which is minus, okay, which is 1870, but in opposite direction. Okay, it is in the downward direction. Okay, now let's draw the three-body diagram of joint A. Joint A has the downward VA, we just calculated. We have horizontal component of A, or you can also call it as FAB. Then we have FAD, and then we have FAC. We are interested in finding the FAC. All the angles are 45 degree. Horizontal component at HA. Also we can calculate by using this, because you know, if you draw the free body diagram here at point B, we don't have any horizontal reaction because it's a roller support. However, the point A is hinged, so we can say that summation of all horizontal forces is equal to 0, and we can conclude that HA is equal to summation of all horizontal forces at A is equal to 0. So HA, that is horizontal force at A, is 1000. Okay, summation of all horizontal forces is equal to 0. So HA is in opposite direction to the 1000 applied force, so both of them has to be equal. So I can say that this this we can also call it as HA, and we can say that this HA has to be equal to FAC cos of 45 degree. Now FAC we can calculate from this 1000 divided by cos of 45 is equal to FAC. So FAC is equal to 1414 kilonewton, which is option D in this case. Yeah. So basically, yes, we don't even need the VA. If we just calculate the HA by using summation of all horizontal forces and then draw the free body diagram, we'll be able to get the answer. Coming towards the next question. This is from the vibrations topic. We have a railway wagon A of mass 10,000 kg collides on the another identical wagon B as shown in this figure. If A is moving at a 5 meters per second and B is at the rest at the time of the collision, the maximum compression of the spring S with the spring constant of 2 meganewton per meter will be. So this is basically a collision problem. We can say there will be the compression of the spring because of this collision, and whatever will be the kinetic energy of this that will be converted to the compression of the spring. So we can conclude that the kinetic energy of the railway wagon will be half of mv square, and that energy will now be converted to the that will be stored in the spring, and this energy in the stored in the spring will be half of kx square after the collision. So you can cancel it, the half part. The mass is 10,000. Velocity is 5 meters per second square. So 10,000 into 5 square, that has to be equal to K is 2 into 10 raised to the power 6 mega Newton per meter into the X, which is like X square, which is the deflection or the change in the length of the spring, and or the deformation in the spring, we can say. And yeah, if we calculate, X has to be equal to 5, X has to be equal to, let's say, X square is equal to 5 square, 10,000, that is 10 raised to the power 4 divided by 2 into 10 raised to the power 6. So this will get cancelled. This will become 10 raised to the power 2. So that is 25 divided by 2 into 100. And yeah, if you write X is equal to 5 by 10 root 2. If you multiply with the root 2 again, yeah, it will be 5 root 2 by 20. So it's a root 2 by 4 meter. Gives you 35.35 centimeter. So the answer is option C in this case. Okay, so at the approximately 35 centimeter is the answer. Okay, the options are in centimeter. Coming towards the next question, this is the last question from this paper. They have given us the spring mass system. The mass is 100 kgs and is held in between the two springs. The natural frequency of the vibration is asked. We can clearly see that both the springs are in parallel, because whatever is the tension in this one spring will be the same as the compression in the another spring because of the moment of mass m. So the deformation will be same, hence they are connected in parallel. When springs are connected in parallel, the equivalent spring stiffness is equal to K1 plus K2, that is 20 plus 20, which is 40 kilonewton. So we can assume it as we have 100 kgs mass attached to the 40 kilonewton stiffness spring. The natural frequency can be calculated as omega is equal to under root K by M in radian per second. So that will be 40 into 1000, because it's in kilonewton, divided by mass is 100. So it is 400. 4 under root of 400 is 20 radian per second. They are asking us the frequency in cycles per second, which is in hertz. So 1 upon 2 pi into omega. And yeah, so 1 upon 2 pi into 20 gives you 10 by pi as the answer. Hence, option C is correct in this case. So that's all from the 2015 paper. Thank you all for watching this video.